So hello everyone, my name is Carlos and I'll be doing the presentation for our group today based on the analysis of the recurrence interval of floods. So the scenario we chose for our project was in relation to civil engineering. Basically, we were hired to consult a multi-family project in the location of Winter Garden. Our objective was to create a hydraulic report on the area to be able to send it to both the county and the city to obtain the permit and to get the job started as soon as possible. But there is a tiny problem. The region, originally being classified in the 100-year floodplain category, is now being argued to possibly becoming a 50-year floodplain category in light of new statistical reports. So now we must revisit our data and compare new data to determine what year floodplain category the region classifies as to make sure our clients make a worthwhile investment before moving forward. Now, what statistical method will we be using for this? We will be using the methods of mean and probability. Using these methods, we'll be able to solve what the chances are that the area will be classified as either a 100 or 50-year floodplain. With some research, we were able to find out the average level of water in Lake Apopka and the total area of the lake, and just how much monthly rainfall contributes over a range of 10 years. In addition to this, we'll be using a probability table to verify what category the zone falls under. Here are the years and the average rainfall in both inches and feet. As you can see, it starts in 2012 with 39.6 inches, and the highest point in the next 10 years is 2014 with 41.7 inches, before bouncing around in the 38 to 40 ranges the following years. Engineers use these data and techniques to make plans as to how to deal with future potential events and see potential threats that they should be wary of. In this slide we see the exact same information from the last slide, except in a more visual manner. As you can see on the right side, we have the years color-coded to be able to distinguish just how close each year was to another year's peaks and lows, and the trends that each one had in the 12 months. So in order to calculate our peak flow of water into the lake, we need to define our runoff coefficient for the area around the lake, as well as take the amount of rain that falls on the area of the lake. This calculation allows us to compare the volume of water entering the lake per year. The period of time in years that it will be before a similar level of water will happen again is given as the return period. Using the relationship between the probability of a flood and when it will return, we can take the average of period we found and estimate the probability of the next occurrence. What are some strengths and weaknesses of the topic or technique? The technique we chose today is mean and probability and how they can help determine whether the project's area is in a 100-year floodplain zone. The strengths of using mean and probability is that we can use the mean from previous years to approximate what the average rainfall for the coming years might look like and use that to determine the likelihood of a flood occurring. However, a weakness would be that the mean is easily affected by extreme outliers, meaning that from previous years could be unreliable if there were any extreme variables, pulling the mean one direction or another, which would not give us a good estimate of future rainfall. Because the project needs to be built on a 100-year floodplain zone, we need to calculate the probability that a flood will happen in the area before a typical 30-year mortgage is paid off, and then compare that value to a general table of annual exceedance probability. As you can see from the flood frequency chart, the flood frequency at 100 years has a 1 out of 100 or 1% chance of flooding in any given year, and the percent chance of flooding during a 30-year mortgage is 26%. Using the previously collected data from Lake Apopka and the results from our previous calculations, we see that the probability of occurrence is 0.986 and the percent yield is 0.01. Therefore, the area of the project is in fact within the 100-year floodplain, which means we are able to proceed with the project. And that is all for the project. Here is where we listed all the sources that provided aid to us in our project. and made sure we were able to achieve the correct results. Thank you.